Hello everyone, we are looking into seismic reflection methods. Right. Towards the end of my previous lecture, we had a look into the various applications of seismic reflection methods. Seismic reflection methods are broadly used to identify major geological structures which are very vital, especially for oil exploration. That is what we had seen in the last class, and we had also toward the end we had a look into how seismic reflection methods are indispensable for oil or hydrocarbon exploration, and we had seen a case study from Nigeria wherein they had effectively used seismic reflection method to understand the subsurface formation nearly up to 4 kilometers below the surface of the earth. This is what we had seen in the previous class, right. What we see on the left hand side is the seismic section obtained by reflection survey, where the reflections indicate the presence of different layers below the surface of the earth. This is the first sequence, second sequence, third sequence and the fourth sequence. Corresponding geological interpretation is given on the right hand side, right. That means we are able to literally see the subsurface of the earth by seismic reflection method. Right. And here is a case study carried out by the United States Geological Survey, wherein, as we had seen on the previous case study, the top diagram indicates the raw seismic section. That means distance versus the time here, right. See, in the previous section we had seen distance versus depth, right, and here we see distance versus time, right. Actually, we will get distance versus time data, but we are able to convert the time in terms of depth if we estimate the velocities of different layers, right. That is what we had seen on the previous case study. So, here is distance versus time axis. This is used mainly to understand the variation in the type of rocks below the surface of the earth, right. What we notice here is I could see a kind of discontinuity here, right, and another discontinuity somewhere here, right. That is what has been demarcated, and here too there is one another discontinuity, right. So, this is how the different geological formations are interpreted from the seismic section. So, what we see on the right hand side bottom is the interpreted geological section from the raw seismic data we have obtained during a survey, right. And the interpretation may vary from person to person, right. See, for example, here we have interpreted as 4 layers, and in between two there are some discontinuities which are also interpreted here, right. That means every individual is capable of or may interpret the raw seismic section in a different manner. However, we need to arrive at a collective decision, right. How we can do that? We may go in for 1 or 2 test boreholes, right. Making use of that, we may have to correct the interpretation we have made. Similarly, in another section here we see, right, on the top is the raw seismic data. Here too distance versus time, right, time of arrival, distance versus, this is the distance, time of arrival, right. It increases toward the bottom, right. What we see here is there are lot of discontinuities, right. For example, here I notice a major discontinuity, right, and here too I notice a major discontinuity, right. Here there is a discontinuity somewhere here, right, and here too, here too. So, this is how we try to understand the stratification below the surface of the earth from the raw seismic data. So, here we have the raw seismic data. At the bottom we see how we have interpreted the raw seismic data in the form of different sequences, right. Their formation may be different. So, how do we check that? As I told you, we may do couple of boreholes, right. Using the boreholes, from the samples which we collect, we decipher the different formations, right. Here you can see geological age also has been Eocene outcrop. At the bottom we have early Oligocene, like that they have interpreted, right. This interpretation of the stratigraphy of the formation obviously is based on the analysis of sample by collecting the samples by drilling couple of boreholes, right. So, here this is the next case study. Here in this study, these group of people have worked out a number of worked on different locations on the west coast of America. This is USA, right, on the west coast of America, right near California. They had carried out intensive seismic reflection studies at number of zones, right. Here you can see at different zones. This is published and this is the link of their publication, right. It is in marine geology, right. And at different windows, seismic reflection survey has been carried out to understand especially the coastal zone of this region, to understand the continental boundaries, or especially the boundary between the ocean, Pacific Ocean and the continent. So, at different sections, the subsurface geological formation has been brought out by carrying out seismic reflection survey. So, here you can see similar to what we had seen on the previous USGS data, right. Similar to that, here at different sections, right, at different sections, right. Here you can see this is 1, number 2, 3, 4 and so on, right. These are all the different sections, right. What is interesting here is we are able to bring out the subsurface formations, right. For example, if you focus your attention to this diagram, right, we are able to demarcate different zones below the surface, right, from the seismic signals, right. This is actually maybe a valley cut basin, right, and these are all the different layers. Similarly, in the next one, we could decipher different sequences, right, as I am marking, right. And obviously, we fine tune this interpretation with a couple of, if necessary, with couple of borehole drilling, right. And similarly, here we are able to bring out the folded structure in the rock from seismic sections, right. So, these are all the advantages of exploration of the subsurface using seismic reflection method, right. Here too, we can bring out a small anticanal structure, right. So, these are all the different sequences, right. How did we mark the sequences? By looking at the raw seismic data as we had seen on the previous page. So, this is how seismic reflection survey helps us to understand the subsurface sequences as well as the locations of discontinuities, and we are able to also bring out some major geological structures. That means how the rocks are occurring below the surface of the earth, whether they are in the form of folds or like linear formations as you see here in figure H, right. So, we are able to bring out the geological structure as well as the type of rocks by seismic reflection method. So, we have seen some case studies, right. We are looking into some case studies. In the same case study, I have taken one section for understanding much more deeply about the subsurface, right. Here, apart from the lines which you see here, you see a kind of blue line here, a green line here, green line. If you leave that lines, what we see is a raw seismological section, right, raw seismic reflection section, right, showing you the distance versus the time. And I told you already, time axis can be converted into depth. How? Right, by assigning the respective velocities of different layers, we can convert that into depth. So, it is an approximate depth. Either you can prepare the section as distance versus time or distance versus depth, right. So, what are all the major discontinuities which we observe? Starting from the bottom, here is the major discontinuity. Very clearly, we could see some major changes in the type of rocks. Next major discontinuity is somewhere here. So, this is how we draw the boundary. Here we see number of some minor folds, right. That means I am able to differentiate the rocks from the raw seismic data, right. And then this is the next major discontinuity. This is the next major discontinuity. And after doing that, we also, to make it much more interesting to see, they have also given coloring. So, here you can see this sequence has been given a different yellow color, this sequence has been given kind of green color, this is in gray color, this is in light pink color, this is again in black and white. So, this is how we are able to decipher various formations. Then we need some additional data to assign the names of the different sequences, especially the stratigraphic names, right, and also the nature of rock, what is the type of rock, which needs some additional investigation, right, maybe by some other geophysical tools or by understanding the borehole logs drilled in this site or in a nearby area. Making use of that, we can also name the different sequences, right. Presence of major structures in the area can also be brought out, right. Here you can see there is a more or less a clear cut vertical discontinuity, right, which is the indication of presence of major geological structure, preferably a fault. So, this is how the seismic reflection survey has helped us to understand the subsurface of the region. In this case, we are able to understand up to around 240 meters, right. And we have seen thus many case studies in bringing out the geological structures. Starting from one case study in Nigeria, we have seen we could understand up to 4 kilometers below the surface of the earth. So, this is how seismic reflection survey help us to understand deeper up to 4-5 kilometers below the surface of the earth. So, on the whole, the methods are helpful in delineating the deposits as well as buried valleys and shallow faults. Faults are the discontinuities as we had seen here, right. This is probably a fault, right. And quaternary deposits are unconsolidated deposits above massive rocks. This may be a deposit, quaternary deposit, preferably may be of sand, and this is a massive rock, right. This can also be called as a buried valley, suppose if the rock extends. So, this is a valley filled with sediments, they can be brought out, and also shallow faults as we had seen on the previous page. And seismic reflection methods are also helpful to understand the hydrogeology of the region, right. That means, once if you can understand the different sequences, then we can also assess whether say a particular formation is capable of holding water or not. Or a typical example, right, this is the ground surface, everywhere we have sand, but imagine the sand is saturated up to some distance. This is the water table, groundwater table, right. The velocity, seismic velocity will be very different. Approximately the velocity may be 1 kilometer per second here, whereas in the saturated it can go up to even 2 kilometer per second. So, this will appear as two different layers. In the seismic section, if you can do seismic reflection survey over here, we may be able to differentiate water table as we see here. There will be a different signal at the top, a different signal from the bottom, right. So, this is how we can help, this helps us in hydrogeological studies. Obviously, in mineral exploration, coal deposits can be easily delineated, and also seismic reflection methods to some extent are helpful to understand the ground before the construction, especially to also understand major utilities below the surface of the earth. These are all some of the other applications of seismic reflection methods, right. On the whole, we had seen broadly seismic reflection methods are helpful to bring out major geological structures. What are the major geological structures? Presence of anticlines or synclines or major faults. Faults are displaced rocks, right. Here the earth, these structures can be brought out. Also stratigraphic traps, as you can see, some small disturbances, changes in the type of rocks between here and here, they can be also brought. For example, if this is a less permeable rock, and this can be a potential zone for expectation of oil, because the gas which has formed will try to escape, whereas this is a low permeable zone, gas may get trapped here. However, this is not possible at a shallow depth, but as an example I am telling you, right. So, we are able to bring out major structures which are present even at 6-7 kilometers below the surface of the earth. These are all different applications. Apart from that, there are some small scale applications, right, which are seen on this page. What are all the major advantages of seismic reflection methods? As we could understand from the discussions we have made in the last two lectures, seismic reflection survey can be carried out from small source receiver offset, isn't it? If you can recollect, right, when you do survey on the surface, these are all the geophones and this is the source, right. And we had seen already, in order to receive seismic refraction signal, the shock wave should meet the interface at critical angle of critical angle, only then it will get internally refracted. So, up to certain distance on the surface, we will not get seismic refraction, right. So, if you want to do seismic refraction survey, we need to calculate the distance between the short point source and the detectors have to be at some distance, so that the signals meet at critical angle, whereas such a restriction is not there for seismic reflection. Here is the source, here itself we will get the seismic reflected data, right. That means it can go and come up. So, there is no such condition. Due to this reason, seismic reflection survey can be carried out by keeping the source and receiver at smaller offset. Offset is the distance between the source and the receiver. So, that is one of the greatest advantage, right. Then the method can also work whatever is the way of propagation of the shock waves with respect to depth, right. That means, in the case of refraction, there are some conditions, right, especially, right, the velocity of layer. Sometimes there may be a layer squeezed between high velocity layers, which may be of very low velocity, which will be a hindrance for carrying out seismic refraction survey, right. Similarly, very rarely we may come across a low velocity layer present at some greater depth. Generally, the velocity has to keep increasing with respect to depth because the rocks are much more solid, more denser. But rare, in rarest of rare cases, vice versa can happen. So, which is a difficult situation for carrying out seismic refraction survey, whereas in seismic reflection such restrictions will not be applicable, right. Seismic reflection method will work no matter how the speed of propagation varies with respect to depth. And seismic observation can be more readily interpreted in terms of complex geology, right. We had seen already here a very complex geological condition of the coast of California in America, right, very complex geology, but still seismic reflection raw data, we are able to draw all these lines, right. We are able to see here itself, I am able to draw a line because I could see the kind of discontinuity from my naked eye, right. Visually, I am able to see the differences. So, such complex geological strata cannot be brought out by seismic refraction survey, right. Hope you can recollect when we were looking into seismic refraction, we had seen some simple cases, right, single layer, multiple layer, dipping layer, right. Suppose if the layers are so complex with so many thin layers, it is difficult to carry out interpretation in seismic refraction, whereas here even a complex geology can be brought out simply by seismic reflection survey. Since in seismic reflection we make use of the entire reflected wave field, right. That means history of the ground motion at different distances between the source and the receiver, right. We are able to bring out a nice subsurface section, especially by inversion, right. Why? Because our interpretation is many times limited to time of first arrivals in seismic refraction, whereas here we use the entire wave field. So, this brings lot of additional information in seismic reflection survey, and because of this we are able to get a image of the subsurface. We have seen several images, right, here too. We are literally able to see the subsurface from the seismic survey. So, these are all some of the advantages of seismic reflection survey. Then the next is, what are all the disadvantages, right. Since we are going to carry out the survey at many source and receiver locations, right. Otherwise, it will be difficult to come out with meaningful images. What do I mean by many sources, right? If this is the surface of the earth, this is source, these are all the geophones, receivers. Right. Just one such sounding is not at all sufficient to come out with a meaningful interpretation. Normally, we need to carry out survey along a profile, right. After completing this, then the source will be shifted here, or we may have source on the other side. So, this is how we may have to travel along a profile, right. Source, the set of receivers, then here is the source, set of receivers are moved here, and this is the source, the receivers are moved to this stage. So, this is how we need to have many source receiver locations to come out with a meaningful interpretation. For example, the sections we had seen previously, they are not obtained only by keeping one source location and couple of geophones. So, we used to do at a number of sources and receivers to come out with a meaningful sections, subsurface sections. So, this makes the survey little bit expensive because you have to spend more time in the field. So, it is expensive. And seismic data processing requires powerful computer. So, it is processing is computer intensive, hence we need some highly sophisticated computers as well as software, right. And not only that, we need really high level of expertise, right. In fact, seismic data processors are really, they are really experts. They are also highly paid, especially in oil industry, right, because their contribution is immense. They need to process a huge volume of data. We are talking today about big data analysis. In fact, since last 30 years, seismologists are dealing with certainly big data, right. Here you can imagine one geophone, usually we use 124 channel, right. Every geophone receives signal from different locations, right, from different interfaces. So, that means the signal received for one shot by one geophone itself is so huge. We need to use maybe let us say 124 channels. Then we are also moving along a profile, which means we are dealing with a large amount of data. To process that huge amount of data, we obviously need some sophisticated hardware as well as software as well as experts, right. These are all some other disadvantages, right. And processing of seismic refraction, that is why seismic reflection data is thus expensive. You can recollect in refraction, we just plotted the time of first arrivals. This is the direct wave, time of first arrivals, this is the refracted data. So, processing this is little bit easy, whereas in reflection is in the form of a hyperbola. This is the hyperbola obtained from one layer, right. That means reflections are coming out from different zones, right. There are different sequences. A receiver here receives reflections from here, reflections from here, and in between there I am drawing a simple case, right. So, in a complex geological condition, the data which we receive is huge, hence processing is expensive. Due to overwhelming amount of data collected, there are also a lot of complications we have to deal with, especially due to the complex earth, right. You cannot deal with the entire amount of data. We make some conceptualization or we make some simplifications, right. We may need to omit certain data, right, and also the experts have to also make use of the data judiciously. The noises have to be filtered, right, and entire data we sometimes is very difficult to handle. So, we come out with some kind of simplifications. That is what we have done in drawing the seismic sections too, right. Here you can see there are so much of discontinuities, but we delineate only some major structures. There is a presence of a fault. Here you can see there is a offset, right. This is how we do little bit of simplification is very much necessary. These are all some other disadvantages. By simplifying, we may miss some important thing, right, which is a disadvantage, right. And reflection require more sophistication as well as knowledge. So, they are actually heavily paid, as I told you. These are all some of the disadvantages of seismic reflection method. In spite of the seismic reflection method's disadvantages, this method is highly indispensable because of the fact, right, without which we may not be able to see the subsurface, especially greater depths of the subsurface we literally see thanks to seismic reflection survey. That actually helps us today to understand the most crucial resource, which is the oil resource. So, thus in the last two lectures we had seen broadly what are all the methods, how we carry out seismic reflection survey, how the data looks like as I had drawn here, right? How we can estimate the thicknesses of layers, right? How we can estimate the dip of the layer. That means if the formation is inclined, how we can estimate the angle of inclination, then how we can process the data to arrive at the image of the subsurface. Then we had also seen some interesting case studies carried out by different researchers in the world. Toward the end, we had seen advantages and disadvantages of seismic reflection methods. Thank you so much. We will continue with the next major seismic method in the next lecture. Thank you.